Thank you, Mike. Hello, everyone. My name is Zafar Mohammed. I'm an Azure Technology Solution Professional at Microsoft with more than 8 years of experience in Microsoft Azure. Today's webinar is on containers and DevOps in Azure. Since we are recording this webinar for on-demand viewing as well, I would like to keep the Q&A session at the end. For all your applications, data, and infrastructure components, the journey to the cloud comes in different forms: migration and modernization, cloud native, and SaaS. You can think of three steps to migration and modernization: rehost, refactor, and re-architect. Rehost is redeploying the application and infrastructure as is to the cloud to utilize cloud capabilities and free data center space. Basically, infrastructure as a service offering in Azure is what you would use. If you have portable open source stack that can be deployed independently of platform, then consider the refactor option, where you could pause that you could quickly deploy your code to containers in Azure. Sometimes refactor could be a step after rehosting. Re-architect is the last step in modernization, where you get a chance to architect your monolithic application into microservices and utilize cloud's app scale and agility capabilities. By the way, microservices is a software architectural style where you are re-architecting or decomposing a monolithic application into multiple small decoupled independent services that communicate with each other using well-defined APIs. The services are independently versioned, deployed, and scaled. Containers is often the hosting environment for microservices as it provides consistent format and desired isolation. Rebuilding option is where you would build brand new application from scratch in the cloud. In this session, we are going to focus on refactor story using containers. Containers are a solution to the problem of how to get software to run reliably when moved from one computing environment to another. This could be from a developer's laptop to a test environment, from a staging environment into production, and perhaps from a physical machine in a data center to a virtual machine in a private or public cloud. Put simply, a cloud, Put simply, a container consists of an entire runtime environment, an application plus all its dependencies, libraries, other binaries, and configuration files needed to run it bundled into one package. By containerizing the application platform and its dependencies, differences in OS distributions and underlying infrastructure are abstracted away. With virtualization technology, the package that can be passed around is a virtual machine, and it includes an entire operating system as well as the application. A physical server running three virtual machines would have a hypervisor and three separate operating systems running on the top of it. By contrast, a server running three containerized applications with Docker engine, an open source container runtime that we'll talk about in a couple of slides, runs a single operating system right here on the left side of the slide. And each container shares the operating system kernel with the other containers. Shared part of the operating systems are read only, while each container has its own mount, a way to access the container for writing. That means containers are much more lightweight and use far um, fewer resources than virtual machines. One thing to note is that because of their small size and application orientation, containers are well suited for agile delivery environments and microservice-based architectures. They are easy to deploy and then they start fast. This makes it possible for you to have higher density, meaning that you can run more services on the same hardware unit, thereby reducing costs. As a side effect of running on the same kernel, you achieve less isolation than VMs. The main goal of an image is that it makes the environment dependencies the same across different deployments. This means that you can debug it on your machine and then deploy it to another machine with the same environment guaranteed. I mentioned the Docker runtime in the previous slide as a way to run the containerized application. So basically, Docker provides an open source container runtime called Docker Runtime that is supported on Mac, Windows, and Linux operating systems and lets you run containerized applications. A container image is a way to package an app or service and deploy it in a reliable and reproducible manner. In this respect, Docker is not only a technology, it's also a philosophy and a process. So there's a process that's involved in packaging your containerized application code, and then building the container image, storing that container image in a public container registry, and then pushing that image from the container registry to your container platform where your applications are going to run as containers. So from this uh, work in this the flow chart that you see on the slide here, you have to have a build machine where you can get your application code built. And once you have the application code built, you build a container image and push that to a container registry. And then once you have the container registry containing the image, that image can be deployed on any of the container platforms, whether on premises or in the cloud, to run your applications or services. When using Docker, you will not hear developers say, it works on my machine, why not in production? They can simply say it runs on Docker because the packaged Docker application can be run on any supported Docker environment and it will run the way it was intended to on all deployment destinations. There are a few terminologies that you need to understand in containerization world. Docker file is what you would need to compose the package or package the contents of the container image. You then use Docker build or Docker compose build command to create image for a single container or multi-container applications. Then Docker run command runs the container application locally with the available images. So right here on the screen, you see Docker run hello world, right? So I can simply run that command. So here's what we can do. I have Docker desktop version installed on my developer machine. Here, when I run Docker run hello world, is simply gonna pull the image from my Docker Hub repository, public repository, to which I'm connected to right now, and run that application locally. So it's running the hello world, it's pulling the hello world image locally on my machine from the Docker Hub container repository and running it locally on my Docker platform that I have installed right here. So if I want to show you the Docker Hub, I can just a sec. I will have to minimize my presentation somehow. And there you go. Here's my Docker desktop that's running. So from here, I'm able to, so Docker desktop is running locally on my machine and I'm connected to my Docker Hub. So from the Docker Hub public registry, it's public container registry. It's getting the image on my local machine, running it, and run successfully. So that's how So this image that I ran, the hello world image, uh, is there on the Docker Hub container registry, public container registry, which they have put there as a sample image to run on your machine, just as an example, right? Moving forward, so you saw that workflow of how you build your code, package it as an container, um, create a container image, push it to a container registry, and then you apply that image onto a container platform, right? So there are so many steps. All those steps can be automated. And those are the steps that are highlighted here. All administration stuff, all of the administration and operation stuff that's involved in setting up your container environment. So all that can be automated. And the task of automating and managing these containers, this large number of containers where you would like to deploy, and how they interact is known as orchestration. Popular container orchestrators include Kubernetes, DCOS, and Docker Swarm. One point to note here in terms of containerization, uh, one of the major reasons why anyone would like to containerize is the limit of scaling in containers. You can scale your applications or services to an unlimited factor. That's one of the main reasons why you uh, would like to use the containerization, or why you would like to containerize your application. Azure provides flexibility. You can deploy containerized applications in your preferred environment, app service or service fabric, or Azure hosted Kubernetes services, or even partner ecosystem like Pivotal Cloud Foundry, self-managed Kubernetes, Docker Enterprise, Red Hat OpenShift, Metasware DCOS. So Azure Kubernetes service that we have here in Azure is the hosted Kubernetes services. So Kubernetes by itself, if you don't know, is actually an open source orchestrator that Google invented or created. What we so open source orchestrator in Azure, that open source orchestrator is being used and hosted um, hosted and in Azure and is managed by Azure. So that way, all those steps or all those orchestration is managed by Microsoft Azure. That's the difference between the hosted Kubernetes services and the self-managed Kubernetes service. Self-managed Kubernetes service is basically your creating a container cluster and you will be managing yourself, and it's not something managed by Microsoft. So that's the basic difference. Um, and Back in the days, we had Azure Container Services until about a few months ago, where Microsoft was letting you create the Kubernetes services, but um, it was not managing for you. So you had to manage it by yourself. One thing to note here is Azure provides DevOps services and tools to accelerate containerized application development, and we'll talk about it in the later slides. Azure also provides services to manage, monitor, and help secure your containers. Azure Container Instances, which is one of the ways you can deploy containers in Azure, offers the fastest and simplest way to run a container in Azure without having to provision any virtual machines and without having to adopt a higher level service. Azure Container Instances is a great solution for any scenario that can operate in isolated containers, including simple applications, task automation, and build jobs. For scenarios where you would need full container orchestration, including service discovery across multiple containers, automatic scaling, and coordinated application updates, you will use Azure Kubernetes services. So some of the features that we already highlighted for Azure Container, Azure Container Instance is fast startup times. Then it does provide a public IP connectivity and DNS name, and virtual network deployment for Azure Container Instances is currently in preview, but should be out pretty soon. So what that feature does um, uh, is it lets you deploy container instances into your subnet within your virtual network. Then they can communicate securely with other resources in the virtual network, including those that are on premises, connected through a VPN gateway or express route. Quick demo. We'll look into the portal about how to create and look into how to create an Azure container instance. So I've just put in some commands over here, which are taken directly from the container instance quick start. So this first command essentially creates a, by the way, this AZ is basically Azure CLI commands. What that is a command line interface. So if you bring up, you have to install Azure CLI. And once you have Azure CLI installed, you can basically run Azure CLI command. Um, Azure login is the command that you would connect to your Azure subscription. So if I put login, it will essentially connect me to my Azure subscription. It's connecting to my Azure subscription now from my Azure CLI command line interface on my development machine. And once I successfully log in, which I should be, it should be coming back soon. It's taking a little bit of time. In any case, so once it logs in successfully, I can run these commands. This is a command essentially the first command. The first command basically creates the resource group. The second command creates a container in that particular resource group, and also pulls the image from the Microsoft public repository. And that image is ACI Hello World. I pull that from the Microsoft repository and apply it over to the container. So that's exactly these command. The second command does. The third command would basically show my containers with the FQDN and the provisioning state. So once I have this, I should be able to see my application up here in the cloud. So this is the container instance that I created right here in ZMCI group, Azure Resource Group. So here's my container instance. Let's look at the public FQDN or IP. We can use either of these to access the website. So let's use this right here and pull this. So this tells that my Azure instance was Azure container instance was created successfully. Is all that says. So your Azure container is up and running. So let's move to the rest of the presentation here. The next service that I want to talk about is Azure Kubernetes Service. Azure Kubernetes Service, like I mentioned before, manages your hosted Kubernetes environment, making it quick and easy to deploy and manage containerized applications without container orchestration expertise. Um, I will show you what all steps are required to actually deploy to a Azure container service from the portal, and to show you how many different steps are there. That will tell you how easy uh, how easy it is now to orchestrate or containerize your application using AKS, which wouldn't have been the case if you were using the old Azure container service where you have to manage everything, and there will be like a lot more number of steps required to deploy your applications in ACS compared to what you have to do in AKS. So AKS eliminates the burden of ongoing operations and maintenance by provisioning, upgrading, and scaling resources on demand without taking your applications offline. As a hosted Kubernetes service, Azure handles critical tasks like health monitoring and maintenance for you. The Kubernetes masters are managed by Azure. Um, you only manage and maintain the agent nodes. As a managed Kubernetes service, AKS free, you only pay for the agent nodes within your clusters, not for the masters. You can create AKS cluster in Azure portal with Azure CLI or template-driven deployment options such as resource manager templates in Terraform. When you deploy an AKS cluster, the Kubernetes master and all nodes are deployed and configured for you. Additional features such as advanced networking, Azure Active Directory integration, and monitoring can also be configured during the deployment process. Um, in terms of management, you have Azure CLI, Azure Portal, PowerShell. It includes auto upgrades, patching, and self-healing capabilities. It supports Java, .NET, and VS Code, .NET and Visual Studio, and .NET Node.js. Um, uh, it offers Azure offers Azure Container Registry, which allows you to store images for DCOS, Docker Swarm, Kubernetes, and Metasphere, all kind of images that you can store in Azure Container Registry. It provides integration with Azure and Azure Active Directory. Supports Terraform, supports Azure services such as Cosmos DB, using Open Service Broker for Azure. In terms of scheduling and scaling, a virtual kubelet can be used to schedule Windows containers on Azure container instances and manage them as part of an AKS cluster. This enables AKS to run just enough capacity for your average workload. As you run out of the capacity in your AKS cluster, scale out additional pods or additional containers. Pods is actually the word for containers instances in or for container in ACI without any additional service to manage. So you can scale out additional pods in ACI without having to worry about creating additional servers to manage. So um, if your AKS ever runs out of capacity or then using the virtual kubelet, you can add those Azure container instances into your Kubernetes cluster. Um, so I'll show you a quick demo on creating Azure Kubernetes cluster in Azure portal. So here are my list of all the resource groups, and here's my GM containers demo resource group, which I've created for putting all my container applications together. So I will add um, just a second. Okay. This makes my Azure connection successful, by the way. There's ACCLI was some issue with my login command last time, but it's working now, just to show you. All right. In any case, going back to the portal, in Azure portal, I'm here in my resource group, and in resource group, I click add to find a Kubernetes cluster. So there's Kubernetes service. Say create. Then it will ask me a few questions or a few options that I'll have to first. So the resource group, I would like to use the same resource group that I have. Then Kubernetes cluster name, I'll just say demo cluster. I'll keep it in Central US with Kubernetes version of 1.1.119, which is the default one. So I'll just use the default one. And here's the DNS name for my cluster. And then I go to the next piece. It's asking for authentication. There's a default service principal that gets created for your Azure Kubernetes cluster, which is what I will leave it with. And here's Kubernetes authentication and authorization. Do you want to enable role-based access control to your cluster? Yes is the default, so I'll just leave it as it is. Then next, networking. Here it asks me for it's giving different options for HTTP application routing if you want to have yes or no. But now I'm not going to use any application routing, so I'll just use no. And network configuration, I can use it basic or advanced. Basic is just like um, it does it puts the cluster in a default virtual network, but sorry, it sets up. Well, I mean, with the basic, you do not have the virtual network configuration. In other words, when you use the advanced, that's when it would let you um, choose a specific virtual network, configure the virtual network, and then set up all the address ranges that you would like to use for the subnets for your cluster subnet. That's something that you're gonna use if in case you really want to have your cluster added to a virtual network so that you can access resources, other resources from through your virtual network integration, maybe within the cloud, Azure within Azure, or maybe on premises. So that's exactly why the advanced network configuration is given. But for simplicity, I'm just going to keep it basic. Uh, Next thing is monitoring. You can enable container monitoring now, and you can see all those logs in Azure Monitor. So I'll just leave it as yes. And the log analytics workspace where those logs are going to go, I'm going to keep it as the default workspace. Tags are something that you can create if you need to for like billing purposes or anything like maybe for like labeling them so that you can group them for organizational needs or billing needs is what you can do. And finally, you review and create. Um, so you can basically so it goes through the process and creates the cluster. And there's one option right here which says download a template for automation. So all this process that you went through step by step can also be done through an ARM template, Azure Resource Manager template, which you can download here by clicking on it. And in future, if you'd like to use the ARM template, you can just run the ARM template from your Azure PowerShell or Azure CLI and it's executed. So it's validated. If I create, the cluster will be created, but I'm not gonna create the cluster. I'll just show you how the cluster looks like that was created in the past. So if I go back here, this is the cluster created, and the cluster has all the things that you'd like to. Since your mom, we enable the monitoring for containers. If you click on it, you should be able to look at the container logs for Azure Monitor. And here's the Kubernetes dashboard where you can go and manage your Kubernetes infrastructure if you want to. And here are the logs that you can look at for your container. So that's the infrastructure logs for your Azure containers is what you can see. Um, by the way, one thing that I did not show you is about the VMs. So when you uh, create the Kubernetes cluster, it basically asks you for the nodes. So here it is. I will take you to this portal where it talks about creating the cluster. So here's the cluster is how you create it. And this, which I did not show you uh, while creating the cluster, was about selecting the node size. So you can select the node size for your agent nodes, right? So the default that's taken is standard ES2v2, but you can as well change the size. So I skipped that step that basically took the DS2v to default nodes, which I could not show you. Sorry about it. But in any case, you do get a chance to select your agent nodes as well when you're creating the cluster. So if you go back, you can, this is the cluster that was created. Here, the option for the scale. The option for the scale is essentially if you want to scale from your current cluster capacity to increase the number of agent nodes from what you have one to something like three or so. So if I move it to three, um, let's say, yeah, it was one. I am increasing it to three. So that what that means is you will have three agent nodes for your application to host the containers or for Kubernetes to be able to host your containers or application in the containers on these three agent nodes. Um, and now going back, uh, so these are the steps that you take, right? For creating the cluster, but it does not finish up there. You have to continue to the next step. Like you have to once you create the cluster, you basically have to get those images from the registry and put those container images from the registry into this container platform or the Kubernetes cluster, uh, which essentially would be running on the agent nodes. For that, you have to use the client tool called kubectl for Kubernetes. Get that using that tool, you should be able to connect to your cluster, connect to your cluster from Azure CLI, and you should be able to connect to your agent nodes. And once you're able to connect to your nodes, you should be able to apply your apply your container image. Um, One thing that I've not talked about here is the deployment part, right? Like you have like you might have a single container or multiple containers. Let's say if your application has multiple containers, all those containers can deployment for those containers can be specified in a manifest file called YAML file. So you here in this example, essentially Azure Vote YAML, you have multiple services. Like the services that we're talking about here is Azure Vote Back, which is like the backend service, and Azure Vote Front, which is like the front end service. So there are two services, Azure Vote Back and Azure Front. So we are defining that deployment composition in the manifest file called Azure Vote.yaml. And once we have that manifest file telling us how to actually deploy the images or deploy the container images, which is again specified here here in this YAML file itself, right? For the backend we are getting those container images from repositories. Like here, we're getting the front vote front image from the Microsoft container repository, um, and the backend repository is basically Redis. So we're getting those images from the repository and applying it to the Kubernetes cluster. So first you connect to the Kubernetes cluster by providing the AKS, by providing the credentials, then you get all those nodes. And once you are connected to the cluster and to the nodes, you apply your YAML file or your manifest, which would contain the deployment plan, like which service goes where and where to pull the image from, things like of that sort. And you can also um, give all the other details that are needed. Like an example is like, where do you want to run this service from? Like Azure container port is 80. So this service is going to be, the Azure Front service is going to be exposed on this container port of 80. So it will be accessible on HTTP once the service is actually running on that container. Once you apply it, then there's just a command to watch how that is being applied. You basically run this command to get the IP, public IP. And once you get the public IP, you should be able to see the application out there. So for my service, I'll show you something real quick. I have this service called, and this is containers demo. I have this service called ZM, a Kubernetes service called ZM AKS demo. I will connect to this service and open up the Kubernetes dashboard to show you how this application is deployed. So to connect to the service, I will have to run simple commands. And let me get those commands for you. Is the command is easy AKS get credentials. So I'm connecting to my service. So I'm connected to the service now, or the cluster. Then I can uh, browse to my cluster. When I click browse to my cluster, it should open up a local proxy here and should pull up my Kubernetes dashboard, which is what you have here. To view the Kubernetes dashboard, you have to connect to your resource group, you have to connect to your cluster, and then you run the browse command to be able to browse to your Kubernetes dashboard. Okay, so what are the services that are running on my Kubernetes cluster? Here are the services that are listed. So these are the services that are listed here. So for any of the services, I have external points. Yes, I do, which is like MHC front, so which is my front end application. The other services, MHC back is my backend service that has all the APIs in it. So if I click on this, this should show up the website that I have. So this is my IP address, public IP, and this is where my website is showing up. So this is my Kubernetes dashboard. While on the Kubernetes dashboard, I showed you the scaling piece of vertical scaling, where you're increasing the size of your cluster itself, like from Kubernetes cluster. But you can also scale the container images or container application that are running on the nodes, right? So right now, if you see my deployments, MHC front, it has two pods running or two container instances running in Azure Kubernetes cluster. So I have like two container image instances running in cluster for this front-end application, which I can increase to whatever number I like. So I say 5 and then click OK. then it should increase it to 5 container instances running on those 3 agent nodes that I have scaled to. So I have AKS cluster with 3 nodes, and on those 3 nodes, I will have this 5 container instances for the backend applications running. So if I go to deployments, now you can see there are 5 out of 5. So there are 5 container instances, or otherwise called as pods in AKS. So those are the container instances that are running. So this is something of all those steps that are needed if you're like um, deploying, if you're developing and deploying in your development environment, right? But you, so there are so many steps that you have to take, like you build your application, you containerize it, you create the image, and then you push that image to the container registry. And from that container registry, you take the application image or container image and you apply it to the container cluster, Kubernetes cluster using the kubectl command. All this can be automated using Azure DevOps. You really don't have to worry about doing these steps every time there's any changes in your application or there are any updates in your application that you want to make. You want all this to be automated, right? All this can be done through Azure DevOps. So I'll quickly show you that as well. So when it comes to Azure DevOps, plan, build, deploy, and operate, right? So this is like a continuous process. You'll have several releases. So you want to make sure that all this happens uh, in a streamlined process without any kind of manual intervention. So for that, you can use Azure DevOps. And I will show you for this specific application that I was showing you is ZM, this particular cluster, ZM AKS demo, is actually deployed um, deployed using Azure DevOps services. So there's a continuous pipeline behind the scene that's actually feeding into this container, into this Kubernetes cluster. So I have the application code that's being checked in by the developers. And once that code is checked in and committed, the build happens automatically, which is continuous integration. And then it is deployed into Azure, into Azure Kubernetes cluster through the release pipeline. So I will take you how that I will show you how that is happening from here. This is my Azure DevOps instance. So here's my application, My Health Clinic, which is actually deployed to Azure, which is what we were looking at on the Kubernetes dashboard. So the Kubernetes dashboard here is actually the source of that code that's deployed to Kubernetes cluster is this project. So if you look at repos, you have all the code coming from here. All the code coming from here. The YAML file, as you see here, is the one that you have used to manually deploy to Azure from your command line, which you do not have to do anymore if you're using Azure DevOps. So this code, once checked in from your developers' machines, it should build automatically if you have continuous integration enabled. So this is my build definition. If you look at the build definition, it's going to show you what all needs to be done once the code is checked in. So once the code is checked in, it is going through several different actions that it needs to take. Like here, it's pulling the image from the container registry and running through the Docker manifest file or Docker compose file, to build all those services or container images. So all that is being done to package up your container images. By the way, we talked about YAML file, but we didn't talk about the YML. The difference between YML and YML is YML, you're basically creating the container images. And with the YML file, you're essentially uh, giving a deployment plan as to how to deploy those multiple containers into Azure Kubernetes cluster using the kubectl. So once all is done, these are the steps that you take for building your container images. Finally, once you have the container images files ready, you basically have them deployed or have them put into the artifact directory. One thing about container registry, this is just telling you using the run services uh, action here. You're just telling what container registry to use and where to push your file. So you're basically pushing your container images into this Azure Container Registry. Um, One of the triggers that I wanted to show you is the enable continuous integration. I do not have it enabled for some reason. I'm going to enable it here to tell the users that as soon as you have the code, you have to basically um, uh, build everything and package it up. Um, and then I want to show you the release pipeline. Once that build pipeline goes fine, it will create the artifacts and it will upload the images onto the container registry. And then comes the release pipeline, where you're essentially deploying your application to Azure Kubernetes cluster. You're taking, if you look at the definition of this release pipeline, we'll see that artifacts is coming from the build pipeline. And then if you go at the tasks that are that you have to do, action items or tasks that you have to do, you're creating deployment and services in AKS. You're basically creating a Kubernetes cluster called ZMAKS demo, and then you're pulling the images from AKS. You're basically pulling the image deployments um, from uh, the registry and deploying it to Azure. So here you can see that the Azure Container Registry path, so Azure Container Registry is this. So essentially pulling the images from the Azure Container Registry and deploying it to Azure. So one other thing that I wanted to show you was this, yeah. So if you look at the create deployments and services in AKS, you're essentially saying, okay, you create the Kubernetes cluster, you apply definition that's there in MHC AKS.yml. So this apply is for the kubectl command. You remember the command that you run from CLI, kubectl is what you would use, what Azure DevOps would be using behind the scene to apply that manifest file to the Kubernetes cluster. That way, those container images will be running on the agent nodes on your Azure Kubernetes cluster. So this is the whole process that can be automated with Azure DevOps. You do not have to go through all those steps. Again, if you look at the pipeline, this is one environment that I'm deploying to, right? There can be multiple environments that you can deploy to over here without having to worry about like going through those steps manually for each environment. As soon as it's built, you have continuous integration enabled, it will build, and then you have continuous deployment enabled to several different environments to test your code, maybe in QA, or you can also have several different parallel environments. You can also have like environments after the environments, right? Once you are in dev A, there's an approval gate here, post deployment conditions, where it says, okay, the development looks good. Let's move forward to the QA. Then it goes into the QA here, the QA environment. Then you have the post deployment conditions here again, with approval required. If approval goes through, then you go into the production environment. So this is the beauty of Azure DevOps, that makes it easy for you to develop your containers and deploy without any hassle. Going back to our presentation real quick. So here's a good application modernization sample implemented end to end that could benefit your .NET application modernization efforts. Moving application from ASP.NET MVC to ASP.NET MVC Core, re-architecting the monolithic application and microservices, and then containerizing these services. It's out there on GitHub for everyone's use, so please go and check it out. For learning purposes, here's a Microsoft Cloud workshop on container DevOps. I would highly recommend you guys to actually go and try it out. It will definitely give you additional learning and containerizing your applications. Finally, Azure Containers instances is expected to GA, and Azure Kubernetes Service is expected to preview in the next few months in Azure Government. All these services are available for you in Azure Commercial. Until AKS goes GA in Azure, you can still deploy Kubernetes cluster in Azure using AKS Engine. AKS Engine provides convenient tooling to quickly bootstrap Kubernetes clusters on Azure. By leveraging ARM, Azure Resource Manager, AKS Engine helps you create, destroy, and maintain clusters provisioned with basic IaaS resources in Azure. For any questions if you have, you might have after this call, please feel free to contact me at mmran at microsoft.com, and I would be glad to answer your questions or get back to you. Thank you so much. It was, I hope you guys enjoyed the session, and looking forward to the next sessions that we have coming up.